Hi everyone, welcome back to Ask Sir Geo. So what we're going to look at here today is a triangle. We're trying to figure out what this angle is right here. And you're doing it by using trigonometry. Now these three groups of letters you see here, they represent something. It's a very quick way to remember setup of a sine, a cosine, and a tangent function. That's why there's an S and a C and a T here. The first one is going to be sine of theta equals, it's going to be the O stands for opposite, the H stands for hypotenuse, which is this. This is the hypotenuse. The opposite angle would be, if you're trying to find the sine of this letter here, for once, you're trying to find C. So the line that is on the opposite end of this angle is this one right here. This one's over here. This one's over here. They're called opposites, opposite line. Now, you also have one that's adjacent. That's what this A stands for. So you have this right here. If you're trying to find the sine of C, the adjacent one is right here. Now, how do you know that it's this one and not this adjacent one? Because this one's adjacent to it right there, right? Well, the reason why we don't use that one is because that is the hypotenuse. That's the line that is that's on the opposite end of the right angle. We never count the hypotenuse as one of your adjacent angles. It's always opposite the right angle right here. Okay, so for C, the adjacent angle would be, the adjacent line would be this one, and the opposite line would be this one. So that's what we're looking at. Sine is opposite over hypotenuse. And we write it that way. Sine is opposite, and I use 3 letters so you know kind of what it is. Opposite over hypotenuse equals, now if we look over here, this is opposite. We're trying to figure out what's opposite of this. It's this, 15. So we write 15. And then you put another line over hypotenuse. Opposite over hypotenuse. So here's the hypotenuse. Where's the hypotenuse? It's opposite this right angle. So it's right here. So that's 25. I'll put 25 there. And you just set up the function for sine C. And that's all they're asking for you to do here. Now, just out of curiosity now, we're talking at sine C here. But what if I wanted to try to do it in cosine or tangent? Because those are 2 other functions. Tangent, other trigonometric functions. So that's when these come in. For cosine, it's adjacent. It's adjacent, and I like to put it as ADJ over the hypotenuse, which is right here. See right there? So, adjacent over hypotenuse. Now, the question is, what is it? Okay, let's see. We're trying to find the cosine of C, which is adjacent over hypotenuse. Well, the adjacent line, remember, it's always this line here. It's never the hypotenuse, because the hypotenuse is opposite the right angle. We don't use it as the adjacent line. True, it is adjacent to C, but we do not use it because it's a hypotenuse. Now we come up here. We see our adjacent line is 20, so we put adjacent, which is 20, over the hypotenuse, which is this line right here. So we're going to put 25 down here on the bottom. Now you can reduce these, of course. This could be 3/5, and this could be 4/5. If you know your times tables, you could be able to do that. All right, and now we come to the last one, tangent. This is tangent here. And I put theta. If you notice, I put theta instead of C. But you could put anything you want, but you're still referring to this angle here. So tangent is opposite over adjacent. So it's OPP over adjacent. So you come over here. Okay, we got the tan is opposite over adjacent. The opposite would be, be this one. That one right there. And that would go on the top. And that would be 20, would be opposite, that would be 15. And then you have the adjacent. The adjacent's right here. And it would be tan of, it would be 20. And there you go. You've wrote 3 trigonometric functions that you could use to find the angle of C. Using the sine function, then you take an inverse sine, and that will be another. But this right here is all about setting it up. And so, just for fun, what do you say we do this? Why don't for your example that you could try, try to find me the cosine and tan and sine, all 3 of these, sine, cosine, and tangent. Find out what it is of A, and write down your problems, and we'll pause. Okay, we're back, and what we're going to do is we're going to say, okay, we know this is sine of A, so we're going to say sine of A equals opposite over hypotenuse, and then we'll say which equals, this is A, this is the opposite, and this is the hypotenuse. So it's going to be 20 over 25. 20 over 25. And then you have the cosine of A, which is the adjacent over hypotenuse, equals, so that would be this would be the adjacent one. Would this be the adjacent one? No, because it's the hypotenuse. Hypotenuse is never the adjacent one. So for angle A, the one nearest it or attached to it is this one right here, 15. So write 15. 15 over, and of course we put the hypotenuse, which is 25 in this case. Then you're going to go down to tan, and tan, all you're going to write is tan of A equals, and if you look over here, it says TOA. So that would be opposite over adjacent. And then you would come over here, you'd look at this angle and say, where's the opposite? This is the opposite line, and this is the adjacent line. We're not using the hypotenuse in this case. So the opposite line is 20, and the adjacent is 15. Now look at this. 20 over 25. Look at this. 20 over 25. 20 over 25. Look at this. The cosine of C equals the sine of A. Look at this. 15 over 25. 15 over 25. The sine of C equals the cosine of A. Crazy, right? That's crazy. But that's what it is. Now, look at this. The tan of C, oops, look at that. The tan of C doesn't equal the tan of A. They're reverse. They're flipped. And that's how it works.